Today I'm going to be looking at the behavior of parabolas in their three different forms. So firstly, in standard form, I've graphed ax squared plus bx plus c, and it's seen in red. Then secondly, there's vertex form, which has been graphed in black, so this one over here. And then lastly, we have factored form, which is in green. So these are the three most common forms that you see quadratics in. And essentially they all create the same shape, as you can see, which is a parabola. They each have their own use, so they each have their own benefits. And now we're going to try to look at how all the letters in all these equations, so the A, the B, the C, H, K, Q, and P, what they all mean and how they affect the graph. So when you first see it, it might seem a little confusing, but they actually all have really specific meanings, which are not that complicated. So firstly, we can see that all three forms share the letter A. There's an A here, an A here, and an A here, which means A affects these graphs all in the same way. So I've used Desmos to help basically see what happens to all these graphs as one of the variable changes. So because we're focusing on A, we're only going to let A change, keep everything else the same. So all of them would be 1, and we're just going to let A play to see what happens. So first we're going to see, we're going to keep A positive just to see if we find any trends as A increases. So now as A is increasing, the first thing you should notice is if you look at the graphs, they're actually becoming narrower, or the two sides, the green and green and red, they're going to start becoming closer to each other. So as you can see, that's happening. As A is increasing, they're becoming narrower, right? So the opposite happens if it goes the other way. So as A decreases, the graphs become to widen, and the closer they get to 0, the wider they are. See how wide they become when A is 0.1? So now we also notice that when A is positive, the graphs are facing upwards, so they're concaved upwards. If it helps you remember, you can also think that when A is positive, it creates a smiley face. And as A becomes negative, immediately the graphs flip. And you see all of them, no matter the form, because the red, the black, and the green graphs, they all flipped. That's to prove the point that the A has the same effect on all three graphs. So as A is becoming negative, the graphs flip. And the same pattern happens. As A increases negatively, so technically it becomes smaller, these graphs become more narrow. So at minus 10, they're extremely narrow, and at minus, let's say, 0.1, they're much wider. So if it's positive, it's facing upwards, negative, facing downwards, and as it increases, as the number increases, the graph becomes narrower.